there's an increasing trend towards using machine learning for content moderation. After taking a look at the limitations of perceptual hashing and other database-oriented methods, we'll take a look at how machine learning is being used in certain applications of content moderation, as well as various limitations of these approaches. Recall in the last module that we talked a little bit about perceptual hashing as one way to moderate content. Perceptual hashing involves uploads of potentially offending photos to a database maintained by the content provider. For example, Facebook. Given a database of known offending content, Facebook computes that perceptual hash, and only the perceptual hash is stored and compared against similar images in the future. So the idea is that anyone who wants to keep a particular piece of offending content off of the platform can upload it to Facebook, have them compute the perceptual hash, and then anything that has a similar perceptual hash in the future might be blocked. This particular method has been used to combat certain types of content such as revenge porn. Now that's a very specific case, but general content moderation is far more challenging. The offending content is infinite. We can't just simply say, here's a piece of offending content, and anything similar to that I would like blocked. Rather, the content that's deemed offensive could really look like nothing we've ever seen before. And there's an infinite amount of new offensive content. And so you can't necessarily apply that general database-based approach. Even if we had ways of automatically identifying content, that ability to identify the content lacks context. For example, we don't know if that content is parody, satire, an advertisement, propaganda, or even a refutation of the original content itself. When thinking about copyright, we also have to ask questions relating to fair use. Just because a particular piece of content matches a known piece of copyrighted content doesn't mean that the content is being used in an acceptable way. For example, as a sample or as part of educational material. Parody is another example where a simple match on content might not necessarily indicate that the content is in fact offensive or illegal. And so general content moderation remains a large open challenge, and it remains necessary to keep humans in the loop for this process. An open question is where the boundary between automated content moderation systems and humans exists. At what point should automated content moderation systems stop making automated decisions and let humans intervene? There's a challenge here between the need to automate to account for the very large scale and amount of content that exists and the potential mistakes that automated content moderation systems may make, either due to classification error or lacking context. Now, it's hard for automated content moderation algorithms to make these kinds of decisions, but these automated algorithms are also ultimately trained based on human decisions. And as it turns out, even humans make mistakes and lack context. Here's an example where Facebook human moderators removed the picture shown here, deeming it as pornography, when in fact the image itself is a Pulitzer Prize winning photograph depicting a napalm attack during the Vietnam War. And so even in the best case scenario, humans can't often make the right decisions. So the turn to AI for content moderation should presumably already be subject to some skepticism. But let's take a closer look. There are various approaches to automated content moderation that already exist for identifying hate speech, pornography, personal attacks, and others. Generally, automated moderation falls into a couple of different approaches. Sometimes the auto-moderation is based on regular expression rules, or rules that basically match patterns in strings. This, for example, is the approach used by the AutoMod moderator used on subreddits, on Reddit. Moderators can tune the rules, and so moderation can work differently in different subreddits. But generally speaking, the rules are written in terms of regular expressions. Other news organizations and platforms are known to use automated content moderation systems based on machine learning or natural language processing. Google has a so-called toxicity reducing API called Perspective that is now processing more than 500 million requests every day. The basic idea behind this particular API is that you can pass it a piece of text and it will return a toxicity score, or the likelihood that that particular piece of text represents some kind of so-called toxic content. Of course, that score and the determination of the algorithm depends on how that particular model has been trained, and it may also be subject to attack. Recently, some researchers have noted that this particular API is subject to both misdetections, as we can see in the top table, and false positives, as we can see in the bottom table. What's notable about these examples is that very small changes in the text can result in dramatic changes in the so-called toxicity score, indicating that these systems still remain fairly brittle and prone to both evasion and attack. One has to be concerned about both false positives and false negatives. False positives results in overblocking, and if an adversary can generate a false positive, that can result in speech being blocked or censored. The implication of false negatives, of course, is fairly obvious. It means that the toxic speech wasn't moderated when someone perhaps would have wanted it to be moderated. Because these automated techniques are based on training sets that are labeled by humans, the techniques themselves may also be biased. Recent research has shown that particular content that females did not find to be as offensive in training sets can sometimes be misclassified as offensive or toxic by classifiers that are attempted to emulate either a male or a female reader. Thus, depending on how the algorithm is trained, overblocking might be biased towards or against particular populations. In summary, there's an increasing need and pressure to employ automated content moderation algorithms by platforms. This problem is challenging because the universe of offending content is infinite, and even humans make mistakes, as we saw with the Napalm Girl example. Thus, algorithms that are trained on data labeled by humans will also be imperfect, biased, and even subject to attack.